Our new chapter, we're going to look at polar coordinates. And you may have heard of them before. I don't know what your experience of these, if any, has been in the past. So let's start off with a normal way to tell someone where a point in two-dimensional space is. So if I said to you that point there had coordinates x, comma, y, you would recognize that as going x in, x units in this direction and y in that direction. But there is another very common way of telling someone where a point is in two-dimensional space, and it's called polar coordinates. So what you do is you take the point and you draw a line, a straight line, to that point. And the distance from that there to there, we call that distance r. Like r in a radius of a circle, right? And then you find the angle that it makes with the x-axis, and we call that theta. And we would call this point, let's call it Q. And in polar coordinates, you would say r, comma, theta. So it's not how far along and up you go, that's x and y. It's how far away from the origin do you go, that's r, and the angle that it makes with the x-axis. Now, this new system, this new coordinate system called polar coordinates is much more versatile and can be useful in a lot of different mathematical situations where the x's and y's don't work. To give you an example, my Calc 4 students today were doing a question involving a double integral. And if you tried to do it using x's and y's, the algebra was horrible. But if you turned it into what are called polar coordinates, it became a very simple question. So this type of idea of turning a coordinate system that uses x's and y's into a new coordinate system called r and theta, polar coordinates, can and is very useful. So what we're going to do is set up how these coordinate systems play well together. So for instance, there's my thing. The x coordinate is r times the cosine of theta. The y coordinate is r times sine of theta. Okay. And what else do we need to do? The x squared plus y squared will equal r squared. And that the tangent of theta is y over r. So these are connections between the x and y coordinates and the r and theta polar coordinates. And there's other connections, but these are some of them. So let me prove some of them. You don't need to know the proof, but just to show you. If I build this right angle triangle and I just pick it up and dump it here, that distance from here to here is x. This vertical distance is y. This distance here is r, and this angle here is theta. So for instance, if I went and said to you, what is the cosine of theta? You would say, well, it's the adjacent over the hypotenuse. My pen's going in this guy. And in this right angle triangle, this side is the opposite. This side is the adjacent, and this side is hypotenuse. So the cosine of theta would be x over r. And if you do a little cross multiply, x ends up being r cos theta. Do you see how I came up with that relationship? So it's not that they're magic. You could actually prove them. Couldn't you find the sine of theta and show me what it was equal to? Let's do a tan of theta, right? If I went and said, what's the tan of theta? It would be opposite over adjacent. That would be y over x. There you go there. So are you convinced that this new coordinate system called the polar coordinates can be used to tell you the location of any point in 2D space, right? I could tell you this one, this one, this one, right? For example, not particularly accurately, but if I draw the X and Y axes in as frame of reference, this point over here, right? Let's say this is my new point. That angle there could be 120 degrees. And the distance from here to here could be 5 units. So if I wanted to tell you the coordinates in polar form, I'd say 5, 120 degrees. Would that make sense to you? Right. Now, suppose I said to you, I've got another point Q, and it's 3, 340 degrees. Well, you'd say, okay, 340 degrees would be something like that, right? It's almost an entire circle. And if you measured from the origin 1, 2, 3 units, theirs would be Q. So every quadrant, any point in any of the 4 quadrants, wouldn't they be polar, right? Great. So we have some new terms that I'm going to introduce right now that kind of takes us into account. Any point in 2 dimensions can be written in polar form. We normally say polar form rather than polar coordinates, but it's the same thing, right? So in polar form, polar coordinates as r, theta. It is called the standard polar form when r is positive and theta is between 0 and 2 pi. So this is the first difference between polar and Cartesian. There are many different ways of telling a point in 2-dimensional space using polar coordinates, right? But when you use an r value that's positive and a theta that's an angle 0 to 2 here, also, if you're talking degrees, because you could be that, then we say it's in its standard polar form, which is typically the way you would like to use a point. I'll give you an example of something that doesn't fit that bill. That is a polar coordinate. It's not a polar coordinate in its standard form because isn't that angle more than 360? Now, if you wanted to see what that guy looks like and you wanted to plot it, right, wouldn't you have to find out what angle between 0 and 360 it was? Right. What is 400 degrees the same as?
Is it 40?
Yeah, don't you just take 360 away till you get a number that works, and 360 away gets you 40. So this would be the coordinates in its standard form, and this would just be a polar coordinate. Doesn't that mean then that there's an infinite number of different combinations that give you the same point in polar coordinates? Couldn't I keep adding on 360, 360, 360, and it'd still be this point, right? It'd still be in the same location. And there are actually uses for that, why that would actually be helpful to have more than one way of describing a point. That one most people can cope with. Let's do another one. That counts as polar. But what would its coordinates be in standard form?
270.
How did you get that?
I added 360.
Right, so don't you just keep adding 360 till you get bored? wouldn't you have to do the same thing if it was radians, right? So just for completeness sake, suppose I had 7, 3 pi and 2, negative a half pi, right? Just for examples.
Just add or subtract 2 pi to each one.
Just add and subtract until you get a number that works. You're comfortable with there are more than one version of the same point in polar coordinates, but you can take them and reduce them to the standard. And that's how you could tell if 2 points were really the same point, right? If I gave you 2 polar coordinates and said, are they really the same place? Couldn't you turn them into the standard form? And if they ended up at the same answer, wouldn't that mean they're the same point? So far, so good. Now I'm going to do something weirder. We're going to look at negative R values. And you might think that doesn't even make sense. You can't get negative R values because R values are measured from the origin to the point, right? And I understand that in the context of the start, that's true. But we do have negative R values. They do exist. So let me show you what one would look like. And how you plot it. Whenever you have a negative R value, right? In this case, negative 3. First thing you do is draw the line with an angle of 30 degrees. And draw it so that it's 3 units long because that guy is 3 units. So essentially, I draw the point with these coordinates, which is the normal one. And then I have to interpret, what does that negative 3 do to this point? Now, you've probably, a lot of you, maybe all of you, have never seen this happen before. What do you think I do then if I want to tell someone to do a negative 330 instead of, this guy here is a positive 330? What do you think a negative 330 would look like? What do you think you do?
Do you flip it over the x-axis?
Well, kind of. You actually go the opposite direction through the origin. So instead of flipping it this way, you kind of do kind of 180 degree turn. So it ends up being down here. Would you agree that's kind of weird looking? But that's how it works. So if you wanted to plot a point with a negative R value, plot the original with positives, right? And then just go the opposite direction. So if this was 3 units long, go 3 units that way. And you've got that guy. Now this guy here, right? See this one here? Doesn't he have another name? Couldn't you get it by just saying positive 3, 210 degrees? Do you see that? Would you agree
Did
that
you
would
just do 180 plus 30? Essentially.
Yes. So isn't the, how would I phrase that? The shortcut way of figuring it out would be, wouldn't you just add 180 to the angle and make it a 3? Let's see how that would work then. If I wanted to plot the point negative 4, 50 degrees, wouldn't it be equivalent to, that's 3 lines just mean equivalent to, the point 4, 230 degrees. And see what that looks like. If you drew an angle of 50 degrees and you went 1, 2, 3, 4, that's where it would be, right? If you then went the opposite direction through the origin, 1, 2, 3, 4, to here, this is the location of negative 450. And I'm just saying that that guy does the exact same job. Isn't that angle 230 degrees? And now you can go a distance of 4. So any given polar coordinate can have positive or negative R values. Also, even if the numbers are all positive, can't there be more than one version of the same answer? Right, just add 360, or take away 360, take away 360, and you would generate a whole multitude of various answers. So now let's look at this kind of problem. How to convert from Cartesian x comma y to polar r comma theta. So suppose I give you a point and its coordinates were 3 comma -3, right? And I wanted to convert that into its polar form. If you plot the point 3 comma -3, it's down here. If I want to convert this into polar, I need to know who r is, and I need to know who theta is. So far, so good. There are formulas for doing that. Do you see this guy over here which says that x squared plus y squared equals r squared? If I rearrange that and I use the positive value, which is the normal one to use, won't r be the square root of x squared plus y squared? So I can get r by taking the x coordinate and squaring it and adding the y coordinate, which in this case is 3 squared plus -3 squared, which is 9 plus 9, which is the square root of 18. And then 9 times 2, I can get 3√2. So there's the positive r value. And you typically always find positive r values. Negative r values are awkward. We don't like them. Now, how would I find the angle theta? Well, theta is this guy, right? Well, if I rearrange that formula, isn't theta the inverse tan of y over x? In this case, theta is the inverse tan of -3 over 3, and theta is the inverse tan of -1. And we are assuming that unless you're told otherwise, that the angles are in the unit circle. So I am looking for an angle, and it's only one angle now, whose inverse tan, right, is -1, right? So if you look at this unit circle, there's only one place where the y coordinate divided by the x coordinate gives you -1. Well, technically there's two, but there's only one of them in the fourth quadrant. Which one in the fourth quadrant are we looking at?
11 pi over 6.
Want to move that a little bit?
Oh, sorry, 7 pi over 4.
Right, do you agree? See it? And so your answer, if they wanted degrees, and let's pretend that the question said degrees, it's 350 degrees. If they wanted the answer in radians, wouldn't you do 7/4? Now there is another place, because typically there's always two answers to any one of these, right? There is another place. Would you agree that up here at 135 degrees, 3/4 pi, won't these two get you also -1? But why am I not using this second quadrant? Why am I using this fourth quadrant?
Because it's the tangent inverse.
Not directly because of that.
Is
Think a
it
little bit more.
because the point is in quadrant 4?
That's it. That's why it's a good idea, isn't it, to do, even if it's a baby sketch, the point, so you can figure out which quadrant, right? Because if you pick any angle that is in the unit circle, aren't you going to get a guy up here and another guy up here that have the same tangent, right? So there's always going to be two choices. And so if you know which quadrant you're in, it makes it easier to decide that it's this one I should be using and not the other possible one, which is up here. Are you comfortable with how you can convert from an XY to an R theta if it is this guy, right? Let's do an ugly one that doesn't have a unit circle in it. Let's pick the point -3, -4. And I'm being asked to turn this one into polar. Only this time, they'll mention something like to 1 decimal place. The minute you see that, you know that you're being told it's not going to be a perfect fit, right? I'm still going to use the same formula. I'm going to do R equals, so it's going to be basically the X guy squared plus the Y squared. I picked these two numbers because they come out really nice. So the R is 5. Oh, I forgot something. In polar form, the answer to this question would have been 3√2, 315 degrees, right? There's your guy, there's your angle, right? So back to this one now. We got that one. To get the missing angle, I'm going to do an inverse tan of y over x. And since I know it's not a perfect unit circle answer, I'm not even going to bother looking there. I want degrees, so I'll make sure I'm in degrees. And if they want radians, then I'll do it radians next time. So inverse tan of -4 divided by -3 comes out with a possible answer of 53.1 degree. And I should have drawn my little fella. Would you agree that -3, -4 is here? And here is the third quadrant. That guy that they just told me is up here, right? Agreed?
Do we have to add 180 to it then?
And because it's a tangent, can't you just add 180 until you, whoops. Until you get to the guy in the quadrant that you're looking for. So your solution to this question would have been 5, 233.1 degrees. So when you're doing polar, if the angle you get is not the one you're looking for, just keep adding or subtracting 180 until you get an angle that's in the quadrant that you know that you're looking for. So if you know the guy's in the 4th quadrant, but the guy you've got's not that fella, right? Keep adding 180s and 180s until he does get there, or take away 180. Normally you only need to do it once and you should get the answer. All answers for degrees need to be 0 to 360. All answers for R are positive. So you're not allowed to say 5, -30 degrees, all right, or 5, 390 degrees, right? You must make sure that your answer is in the range 0 to 360. So you may have to doctor your answer if it's too big or too small to fit that range, because we want a standard answer. That way everybody gets the same answer. Are we good? Any questions so far? Okay, let's now look at the opposite way around. How to convert from polar r comma theta to Cartesian. Aye. That way round is a lot easier. You don't have to do little tweaks and make things work. You pretty much use these two formula here and everything's done for you. I'll show you what I mean. Suppose I had the P and it was 5, 30 degrees. The X coordinate is r cosine theta and the Y coordinate is r sine theta. So it's going to be r times the cosine of 30 degrees, and it's going to be r times the sine of 30 degrees. And those ones happen to belong in the unit circle. And r happens to be 5, so I guess I should put 5 in here. Cosine of 30, there's 30 degrees, root 3 upon 2. So 5 root 3 upon 2. Sine is a half, 5 times a half. And there's your answer. 5 root 3 upon 2, 5 halves. Do you notice I didn't worry about which quadrant it was in? The formula takes care of that. I didn't even need to worry about negatives or anything. In fact, you can convert anything you like using just these two formulas. Let's do one that we wouldn't typically want to do. Negative 2, 40 pi. Would you agree that is zooming around a circle an awful lot of times? And isn't that negative 2 kind of hard to figure out where it's pointing? But X is just going to be negative 2 cosine of 40 pi, and Y is going to be negative 2 the sine of 40 pi. And 40 pi actually just ends up being cosine of 0. And that ends up being the sine of 0. And this is 0, and that's negative 2. So there's your answer. It's at negative 2, 0. I'm going to move over and show you some of the weirder questions that you get in WebAssign. I kind of like these questions because they're going to get your brain to think. One of those four guys, P, Q, R, or S, is this fella. This is polar. One of these four guys. All you need to do is figure out which quadrant that guy would be in. They've given you the x-axis. The y-axis is right up and down here if you wanted to know where it is. 4 possible places. Where do you think this guy is hunting? And how are we going to figure it out? Because it's not a typical question, but I know how to do it. Tell me how to do it. How would you do it? Don't need to know the answer because you might not be able to do it in your head, but how would you do it?
You'd subtract 2 pi until you got in between 0 and 2 pi for the...
Okay, right. Yeah. Let's suppose I did this. How would I take care of the negative 4?
I would look at the point P because it goes up to 4 and then just reflect over.
Right. So if I ended up stopping at P, R would be the answer, right? And if I end up stopping at R, P would be the answer. So that's what you're kind of saying, switch places?
Yeah, I guess.
That's what I'm hearing. If you take 101 over 4, isn't that 25 and 1/4 pi? Right. And what you just said is really visual and really cool. And now I'm going to show you just a different way. I'm not saying this is better because I don't think it is, but a different way of doing it. Couldn't I find the X and Y coordinate of this ugly guy? And wouldn't that tell me what the quadrant is, right? Now, I'll do it in a minute, but can we pretend that this guy is a positive ugly thing and this is a negative ugly thing? Which quadrant will you be in if the X is a positive thing and the Y is a negative thing? Don't even care what the thing is, just that it's positive and negative.
Quadrant 4.
And if you're quadrant 4, you'd be S. You see how this is going to work? So I'm just going to go X equals -4, the cosine of 101 pi's. And while I'm at it, may as well do the Y. -4, the sine 101 over 4 pi. And the way that you were telling me about subtracting 2 pi is totally fine. I like that as well. This is just a different way of tackling it. So I'm just going to go -4 times the, oh, no, I'm not. Make sure you're in radians. Do you know the number of times you are in the wrong mode and you don't know it and it screws the thing up? So this is radians. So -4 cosine 101 pi divided by 4 gets me a positive number. And then I'll do the same thing again, -4, and the sine of 101 pi divided by 4. And the answer I got was also a positive thing. So which quadrant am I in if both things are positive?
1.
And the picture that we had, P was in 1. So the answer would be P. So I'm returning back to that question. I'll show you how we tackled it. That's the guy. Pick P. Are you cool with that way of doing it as well? There's another version of that question. Now here's a different question. There is the point Q, it's described here. Find its polar coordinates. So we shouldn't need to do too much here. Don't I need to know what the R value is and then what the angle is? And because I've written it this way, I know I want the angle to be in radians. So what would the R value for Q be? Just looking at the picture. What's the R value of Q? How far away from the origin is it? That's the same thing.
3.
Yep. 3. Now, you start at the x-axis and you go the usual anti-clockwise direction. So in radians, how big is this angle? Starting at the x and curving round to where Q is. Starting here and then curving like a clock anti-clockwise to here.
3 pi over 2.
Okay, so 3 pi, oh, good, over 2. And that's it. In this question here, you're shown the angle and you're shown the distance. You see it's visual, but isn't R going to be 1? And won't this guy be 3/4 pi? See that? So if I was going to find the, as they call it, rectangular coordinates, I call them Cartesian.
Wouldn't R be 2?
Wouldn't R be
I think
2?
the 1 is.
Oh, the 1 is 1 mark, I hear. Yep. So definitely go for 2. Now, to get that guy, isn't it going to be 2 cosine theta? And won't this one be 2 sine theta? So if you have a homework question that you have to put in theta, just type the words theta and it figures it out. Now in this case, theta is what, 3/4 pi, that fella? So I would go here, I'd put in my fraction button, and it would be 3/4 pi. And then this guy over here would also be 3/4 pi. But I wouldn't do that on a calculator, because if you did that in a calculator, you'd get numbers like 1.414. If you know an angle is in your unit circle, shouldn't you get the sines and cosines from your unit circle? So this guy here, for instance, is -√2/2. And so this would be -√2/2. And the sine of 3/4 pi is positive. Kind of taking you through what the working would look like. And they cancel down, and all you end up with is that fella. And that fella. And although they don't have the X and Y axis drawn, I'm comfortable that that's a good place. Right, so -√2, -√2, that makes perfect sense to me. Why would I be worried if I thought the answer was that? In X and Y coordinates, why would I be worried that this would be the X and this would be the Y coordinate for that picture in front of us?
Because then it would be in the fourth quadrant.
And we know it's not, right? It's not in that quadrant, right? So when you're doing these kind of questions, can you visualize which quadrant your answer is saying it's in, and then look at the picture and say, this is the answer I had? Yeah, that makes sense. Wouldn't that be over here in the second quadrant? Right. So that's a way to keep your eye on the thing. And this one's pretty straightforward, so let me leave that. So that's some of the kind of ways in which they ask you questions in this. They then go on and they do pretty standard ones where they ask you to change rectangular to polar, and the numbers are pretty straightforward and they all belong in the unit circle. And it looks like they're pretty much all radians as well. So I'm randomly just stopping at a question and showing what it looks like. This is question 14. And we have an X and Y coordinate. The X is 7√3 and the Y is -7. And we're being asked to find what it would be in polar. Obviously, that's the bit that tells me it's polar. So there's the X value, there's the Y value. To get R, we do this guy. Be careful when you see square roots, especially if you're going to do something like square them. If you take 7√3 and you multiply it by itself, which is another 7√3, you get 49 times 3. So you actually get 120, 147. Are you happy about the 147 that I just got there? 7√3 times another 7√3 gets you 49 times 3, which is 147. And -7 squared just gets you 49. And that adds up to get you 6, 9, and 1. And if you're really, really lucky, you might get an answer like the square root of 196. Can that simplify?
Yeah, it's the square root of, or sorry, the square root of 196 equal to 14.
Okay, so show you that. See, you might not quite get perfect numbers like that, but couldn't you get things like the square root of 20, something like that, where you could simplify it a little bit? So we have the R value. Now we have the trickier part. To get theta, we have to take the inverse tan of the y coordinate over the x. It's going to have to be the inverse tangent of -7 over 7 root 3. And there's no point in you doing that on a calculator. The decimal you get won't be usable. We need an answer from here. They're going to be from the unit circles. So I'm looking for the inverse tan of -1 over root 3. That's what it simplifies down to. So somewhere in this group, there is a point, well, there's two of them, where if you take the y coordinate and divide it by the x coordinate, you get 1 over root 3. -1 over root 3. Where is that guy hiding? He's in here
Is
somewhere.
that 5 pi over 6?
Let's check it. 5 pi over
Sorry,
6.
no, it's 2 pi over 3.
Have you changed? You got a different answer? Or
Yeah, it's 2 pi over 3.
Right, so we're looking at 2/3 pi, which is up here, right? And if you take the y coordinate, it's this number, and you divide it by the x number, do you end up with this guy? Well, I guess the best way to find out is by doing it. If you take this guy and you divide it by this guy, it's the same as the top one multiplied by the reciprocal, and not quite, agreed? So do you want to change your mind to that one
Yeah.
then? But that's what you do, because it's not obvious, you know, especially when you're talking about fractions over other fractions. But I'm just taking this one all the way to the end. There. Can you see that that one works? But can't you sometimes say, okay, that doesn't work, but I know that one will, right? So you know it's one or the other. So we have one answer that is possible, and I'm only going to call it a possible answer right now, because there's two choices. It could be 5/6 pi. Okay. Or where is the other place where that same combination happens, at least a similar combination happens, that could give you the -1 over root 3 that we're looking for? There is another one in the unit circle that does the same job as the one we just used. Where is that guy hiding? We know this one works. Where is the other one?
$11 pi over 6.
Okay. So now we have to decide which one is it, because it's going to only be one. Can't be both. And the clue that I would use is up here. What quadrant is this point in? Which quadrant is this point in?
Fourth.
And so which one of these two angles should I choose because of that?
11 pi over 6.
Because it's in the fourth quadrant. Do you see how much extra little tweaky work you have to do to, get all the bits working out here? It's much easier to do polar into XYs much easier, because you just have two equations and you get the numbers from your unit circle and you're done. When you try and do the opposite way around, it's a little bit, well, which answer should I use? How do you get a tan? Because I know how to get sines and cosines. Aren't they just x and y coordinates? They're easy to find. But isn't finding tangents a case of trying to do this guy be divided by that guy, right? Y by x and simplifying in your head. Not really the same thing. Let's try one more of these guys. Keep that one there, I think. This one I'm doing is question 16. Now this one's going to test your algebra skills as well as everything else. It's the last one of the batch, because after that we're doing something different. So there's my x coordinate, right? There's my y coordinate. And to get r is not normally going to be a big deal. And squaring that guy gets you plus 6, and squaring that guy gets you plus 18. So I get the square root of 24. Can you simplify the square root of 24, even if it's just a little bit?
Wouldn't it be 4 root 7?
Okay, so let's see, 4 times 6, and that simplifies down to 2 root 6. Pretty close. Right. Now, to get theta, the missing angle, again, we're sticking to radians. It's going to be that. So I'm going to have to find the inverse tan of negative this fella over negative this fella. So I'm going to do that at the side. The way that's written, I'm going to have a lot of problems finding an angle in the unit circle that matches that. So two negatives cancel out. Is there any way that you could rewrite this fella? Any simple way of root 18?
Well, it's not the way that you're doing it, but what I would do would be a big square root of 18 over 6, and then you could simplify 18 over 6 and take that.
And you got?
Wouldn't that be 3, square root 3?
Yeah, square root of 3. That works. Or you could call this guy, which is much longer way of doing it. I agree with you. You could do that. They cancel down, and you get 3 over root 3, which eventually will become root 3. So there's a shortcut, or there's a scenic route. But they both work. So now we are after that guy. Whenever I see a square root of 3, whether it's 1 over root 3 over 2, whatever it is, if you see a square root of 3, you're going to be looking at 30 degrees, 60 degrees, 120, 150. Do you notice that I'm skipping out these guys? There's no way you're going to get a root 3 with these numbers, agreed? So since it is positive, right, would you agree I should be looking somewhere in the first quadrant? Because a y divided by x being positive is here. And the other place is over here, right, in the third quadrant. So let's focus on this one first, because there are going to be 2 answers and then we'll throw one away. In the first quadrant, which one of these angles, if you take the y coordinate and you divide it by the x coordinate, simplifies down to root 3?
Pi over 6.
Okay, so if we take the y coordinate, which is 1, and divide it by the other guy, 1 over root 3. Does that match? Okay, so if that one doesn't match, what's the other one that will match then? Y divided by X. Root 3 upon 2 divided by 1 upon 2 becomes, this is the long way of calculating it. See, it works. So let me show you a quick thing that might help. Suppose I'm looking at what happens at that point. Have you noticed that every single time the 2's cancel? So you really only need to worry about what's happening at the top. Would you agree that root 3 over 1 works? Let's take this second one, this one here. Root 3 upon 2 1/2. If I want to know what you get out of that, there's your X, there's your Y. Don't you just get 1 over root 3? You see the difference? Right. Since we have figured out that the one that gives us the guy we're looking for is here, right? Which is what, pi upon 3. All we need to do is figure out where the other one is. This guy gives you a tangent of root 3. Where's the other one? Pi upon 3 works. Where is the other one? I'm looking for an angle whose tangent is root 3.
4 pi upon 3.
4 pi upon 3. Have you noticed that when you do these, if you know one, isn't the other one just add pi? You notice that? Pi upon 3, add 1 pi, gets you 4/3 pi. And okay, which one of those two is actually the one that we should use for this coordinate?
Because both of them are negative, it would be the one.
Oh, they're both negative. And I put the wrong one down. I apologize. Or you may have said it right, and I just wrote it down wrong. That's possible. Right, it's this guy here. Right. So which one we're looking at? We've got this one. There we go, 5/3. So back to the question, which one of these two choices is the one that should be used because of the coordinates that this is? Would you agree that guy's in the 4th quadrant? Is he? Oh, sorry.
No, it's in the
No, I was
third
right.
quadrant. You were right.
I was right the first time. I
I was
taught
just saying
myself
that because they're both negative, it has to be in the third quadrant.
Okay, I agree. So back to the answer, it has to be this one then, right? So that one goes. And we are finished because we now know R is that, and the angle is 4/3. So you are going to get yet more practice at handling unit circles. So quick little recap. If I gave you a point like 5,12, you should be able to turn it into its polar coordinates. If I give you polar coordinates, you should be able to turn it into its X and Y coordinates. Okay, that's pretty much it. If I give you polar coordinates and it's outside its range, can't you just keep taking away 2 pi's till it works? And if you have a negative R value, hopefully you can plot a point that looks like that. That's kind of where we are right now. So
what if it's not on the unit circle? So you said 5.
Oh yeah, if it's not in the unit circle, the answer is going to be 21.2 degrees or
Okay.
1.23 radians. I didn't see one. I might have missed one, but if I did, it's only one question that doesn't have it. You'll know that it is radians because they always seem to have that, right? And if you see that, you know you're talking about an exact value. So I'll do a quick scan because they finish at 16. I'm just scanning through as we go through this. Yep, every single question is radians and none of them are decimals. So they all end up being in terms of radians. But the last thing for today is polar equations. And how to convert equations written in the form y equals f of x. So, what does a polar equation look like? Well, let's talk about Cartesian equations. You get guys that look like that, 141. You could get guys looking like that, right? They're examples of equations. You could get guys like 6x equals 7y, but I would probably change that, but you could get that. So these are all equations that use these x's and y's. So what do polar equations look like? Well, polar equations look like r equals 2, theta equals pi upon 4, r equals 2 sine theta plus cos theta. They look like, I know, r is r squared is tan theta plus 1, right? Anything that contains r's and thetas are polar forms, polar equations. Anything that contains x's and or y's are Cartesian form. And we're going to look at how do you change from these guys into these guys. Let's show you our first example. The equation that we're going to convert is that one. Here we go. Step 1. Substitute x equals r cos theta and substitute y with r sin theta. So this becomes 6 times the cosine of theta, and this guy becomes 6 times the sine of theta, and that is step 1 done. And forgot my little r's. Step 2. This is a vague step. Simplify as much as possible. So I've got 6r cos theta going to equal 6r sin theta. And we're going to have to bring some of the skills we picked up in the last few weeks to make this simpler. Right? As long as you do it to both sides, it's okay, Ro. Any suggestions for what might be a good start? What could I do to both sides here to make it simpler?
You could divide both sides by cosine.
Oh, I like it. So 6r is equal to 6r, and I'm going to write it down, even though some of you might already think, well, I know what that is. So I've now got 6r equals 6r tan theta. That's a good start. Anything else you can do to both sides? Well, let me phrase it this way. There is something you can do to both sides. What is it?
I mean, technically you can divide each side by 6r, but I don't know if you want to do that.
And it's good to hesitate, because normally you don't want to do that. But like in every rule, there's exceptions. So this time we do want to do that. That's good. Would you agree it's much nicer? Now, the next step is that. So how did I get from here to here? What did I do to both
Took
sides?
the tan inverse of 1.
Yeah.
And on the unit circle, it would be pi over 4 or 5 pi over 4.
Yeah, I'd pick the pi upon 4.
Yeah, because both coordinates are positive.
Looking good. And there is your first equation. Theta equals a number. Okay. One last one for today. We'll be finished. So here it goes. This one's actually going to be a really quick one. Right, basically there's only 2 steps, right? Do the substitution, then, start using trig identities to make things look pretty. So this fella is going to be r cos theta, and then I square it. And the one next door to it is going to be r sine theta, and then I square it. And it's going to equal 36. So far, so good. Now, if you multiply this by itself, you get r squared cos squared theta, and you get r squared sine squared theta, again equaling 36. Right, you can do more. Left-hand side, what can you do to the left-hand side to make it look prettier?
You could take the square root of everything.
Oh, interesting thought. Hold that thought, because I will do what you said, but not yet. Want to do something?
So because cosine squared theta plus sine squared theta, can you technically do that and make it
Yeah.
equal to 1?
Yeah. How am I going to make that happen?
You factor out r squared.
Okay. So a lot of you might be seeing, a couple of, putting a couple of steps together, right? Well, I would do that and then I'd do that. I'm just putting them each down because not everyone yet can see all these steps. Now, I think you mentioned that that's 1, isn't it?
Yeah.
Now, someone went and said, take the square root of both sides. Doesn't that seem reasonable? And if you take a square root of both sides, what do you get this time?
6.
6. Now, technically, couldn't you get -6? But don't we like positive numbers? So we'll pick that one. Oh, in fact, that kind of makes sense. If you plot all the points whose distance away from the origin, that's what r is 6, can you see that what you make is a circle of radius 6, which is exactly what that is. So